Hey guys, welcome back. Today we are going over everything I have done on the interior for the electrical, the plumbing, the solar, and also the gas lines. So I know this stage of the house for DIY tiny housers is really scary. For electrical and gas and everything, you just hear these horror stories of fires and everything blowing up, and you know, you have it in your head, you can't do it yourself, you need to hire a professional. Well, I started researching, reading books like DIY Tiny Electrical, and once I started wrapping my mind around it, I thought, okay, you know what, I can do this. I can try it out myself, and then later on, I can hire a professional to check over my work. And as I was doing it, reading more, figuring it out from YouTube, like, it became super simple. It started clicking very easy, and I became really comfortable with doing all this. So I'm gonna show you what I've done on the inside, and hopefully you can start getting the courage to do it yourself too. I totally do support like having a professional check over your work at the end, but I definitely think that everyone should try doing it themselves, because these are life skills, and then you will be intimately aware of how your tiny house is run for the electrical, plumbing, and everything if there's ever a problem you need to fix. Well, with no further ado, welcome to the interior. Okay, it's time to test it out. See if I have power. I do. Got my fire extinguisher here because I do not trust myself. There's no telling where I went wrong, but hopefully it doesn't catch on fire. Yeah. And I have power. Okay. No sparks. That's good. So we're starting with that light. It's the only one hooked in right now. And so I'm going to turn on the breaker. Should see this light up. And then we'll see where we go from there. Go. Hey! I have light! There is now power in the tiny house, and nothing is on fire. Welcome inside the tiny house. So today I'm going to give you a rundown of everything I did for my electrical, my solar, my plumbing, and my gas lines. What to start with? Well, since you can see the lights are on, let's start with the electric. So before I take you over to the electric box, let me show you this inlet right here, which is the outside inlet for power, for shore power. It is a 30 amp shore power inlet. It's running along to the breaker box with a 10 gauge wire. Alright, so if we follow this wire all the way over here, welcome to the breaker box. So you can see the 10 gauge wire running into the bottom of the breaker box, which is supplying the main shoreline power. So this is whenever I want to hook up to a campsite, whenever I'm at a friend's house and I can just hook directly up to their house, that sort of thing. So the 10 gauge wire is bringing in 3 lines. Again, black is hot, white is neutral, copper is the grounding wire. As we come into the box, you see that the black wire goes directly to the middle bus bar, which is here in the center where all the breakers are connecting to. That is my hot bus bar. That is where all the power is coming into. The white lines all go up to this top bus bar that's sitting above the breakers, and it creates a circuit so that power can flow through. Finally, I have all my bare copper wires coming over to the back here, which is coming down to this grounding bus bar here at the bottom. This grounding bus bar is then connected to a 6 gauge copper wire that goes down through the bottom of the breaker box, down through my wheel well, and eventually goes to the trailer. And that'll provide some protection for the house so that if there's ever an electrical surge or anything, all the appliances are protected inside because the surge will travel through the grounding wires out to the trailer and then down to the ground. Now you can see I've installed 4 breakers in this breaker box. This one to the most right-hand side is a 20 amp breaker, which is supplying my eventual AC unit, which will go over here in the corner. These 2 in the middle are 15 amp breakers, and they're supplying the left and right sides of the house for all of the electrical outlets. And finally, to the most left, we have another 15 amp breaker, which is supplying all the lights and also the bathroom fan. Now coming out here at the top, you see different colored wires. So again, orange is the 10 gauge wire, which I showed you coming in from the shore power inlet. 10 gauge wires can transfer 30 amps of power. So 30 amp inlet, 30 amps of power directly to the breaker box. This yellow wire is a 12 gauge wire. It runs all the way to the other side of the house, which it'll eventually supply my AC unit. 12 gauge wires can transfer about 20 amps of power. So since the AC is a bit more of a power hog, I will have this 20 amp wire so it doesn't flip the breaker. Finally, for all the electrical outlets, the lights, everything else in the house, I use this white wire, which is 14 gauge wire. 14 gauge wire can transfer about 15 amps, so it's much better for most of the rest of your electronics, your lighting, everything like that. So I think the easiest way to go about this for explaining and conceptualizing how the solar connects to my system is going from top to bottom. So starting at the very top, which would be the roof, I put in a 100 amp solar panel. Eventually I'm going to have 4 of these for a total of 400 amps coming in. But just because of budget restraints, I'm just going to add those on slowly as I can afford them. So here you can see 2 lines, which are my hot and neutral coming from my solar panels. These are running all the way down over here to my breaker box that's specifically for solar power. So coming into the box, we have my hot wire, which is connected to this 30 amp breaker. That means I can turn off my solar panels in case of an emergency, or I'm traveling, or I just don't want them on at the time, and then no power is coming into the system from the sun. Next, the hot line travels over and joins the neutral line and goes up into this compartment. This is my charge controller, which is basically the brains of my solar system. This is a 40 amp capacity charge controller from Renim, and it is their Rover MPPT charge controller. So you can see my hot line coming in to this fuse box. That's just so that if the solar panels get some kind of surge, it's not going to destroy my entire system. Then they both connect up into the charge controller into the 2 terminals spaced for the solar inlets. It also has this little line running down towards the batteries and just keeps tabs on the temperature to make sure that they're not overheating. So we have the 2 inlets for solar power coming in over here on the left-hand side. Now on the right-hand side we have 2 outlets, the red being positive, the black being negative, coming all the way down across to my batteries. So my batteries are AGM batteries. which if you are doing solar, you really generally have 3 types of batteries you can choose from. The first type is flooded batteries, which you have to constantly top off with water. They can release chemicals that really aren't good to breathe in, just generally something you want to stay away from. The second type are AGM batteries, which is a little bit of older technology. They're pretty heavy, and you can only use them up to 50% of their capacity. Otherwise, you could run the risk of ruining your battery. You also have to replace them every 3 to 5 years. The last type are lithium-ion batteries, which are sweet. Lithium-ion batteries are so much lighter, they're smaller, easily compacted into a compartment. They also can take up to 80% usage of their charge without harming the battery, so you get to use more amp hours of your battery. The only issue is they are super expensive. This sucker cost me about $150 on Amazon. Now, if I was going to get a 110 amp hour battery that was a lithium-ion battery, I would get 80% more usage out of it. It would be much lighter, but it is also so much more expensive. I believe like $400 or $500 per battery. So eventually one day when the technology is not so new, I would totally love to transfer all over to lithium-ion batteries. But for now, AGM batteries suit me just fine. And eventually I'm gonna have 3 of these. That would give me a total of 330 amp hours, which usable since it's an AGM battery, only 50%, which would be about 165 if my math is correct. So coming in from the charge controller, so first we went from solar panels to the breaker box for the switch, then over to the charge controller, then we came down from the charge controller and now we're at the battery. So we have a red line coming in and a black line coming in. Red again is your positive, black is your negative. Now coming from the battery, we have 2 more lines and they're actually coming up to this power inverter. So batteries are DC power, but my entire house is run on AC power. I did this just because I didn't want 2 separate systems, some for DC circuits, some for AC circuits. That would mean I have to constantly have my battery on even if I'm hooked up to shore power. And it would also mean I just have to do a lot more configuring to make sure this whole system worked. So the only downside with having your entire system run on AC and running off batteries is that you lose some of your power, like 10% of your power during the transfer through the inverter. So this is my pure sine wave inverter. I know the logo is upside down, but that's just how it had to go for the wires to line up correctly. It gives about 1500 watts of continuous power and also has a surge capability of 3000 watts. So that should be more than enough than when I need to power the system and still stay protected. So this red wire looks a little loopy because eventually I do want to put in a fuse here just to give some extra protection for the inverter and the battery in case there was ever a surge through the system. The inverter comes with this little handy switch which you can power it on, power it off, and also tell if there's a fault. I'm eventually going to have this sitting right above, right here on my desk. So over here on the left hand side we have 3 AC outlets. I'm only currently using 2 AC outlets, and these are connected to 10 gauge wire. So coming out of the inverter, the wires come down here to splice together. Then they head up to this breaker box and are connected to this side, the right hand side, which is also a 30 amp breaker. This is so I can turn the battery connection off from the main breaker box whenever I want to, which is really important whenever I hook up to shore power. I cannot be hooked up to shore power and my batteries at the same time, or I will blow my inverter, and that would not be good because this was like 250 bucks. So from this 30 amp breaker, we come up and over to the main breaker box. And for the middle bus bar, which is my hot bus bar again, it had 2 sides for hookups, one over here and one over here. So I made this side my hookup for shore power and this side my hookup for battery power. Just to recap, I have power coming down from my solar panels, coming into the breaker box so I can switch them off whenever I need to. Then it comes over to the charge controller, which is the brains of the solar system. It makes sure the batteries don't overcharge. It just keeps tabs on everything to make sure it's all running properly. Then I have 2 lines coming down over to my battery, then coming up from my battery over to the inverter to switch DC power to AC power, then coming back up to this breaker box to a 30 amp breaker, which can turn on and off from battery power. And then it comes over to the main breaker box. to sync up with the entire system. And that's solar power. It's pretty simple, pretty straightforward. Right now, my system is a little smaller just because I only have one battery and one solar panel, but it's really awesome doing your own DIY solar system because you can expand it whenever you want, forever, however much you want. So instead of buying like a big Goal Zero pack, which can cost you about $1,500 plus whatever you have to spend on solar panels, this system, what I have right now, again, this is all currently running on solar, it cost me $700. So when I expand the system to 3 batteries and 4 solar panels, so the batteries are $150 a piece, that's $300 for the 2 extra batteries and $300 for the additional solar panels. So it'll be around $1,300 for my entire solar system, just so I can be off-grid. So the next thing I want to talk about is what a lot of people are excited to talk about, which is lighting. So for my tiny house, I have 2 lights over the bed, 1 light over the kitchen, 1 light over the desk, 1 in the bathroom, and 1 in the hallway. So for all my lights, I had to make my own light boxes because I have a 4-inch ceiling, and most houses have 6-inch ceilings, and that's what most recessed lighting is designed for. And the lights I got is from a Chinese company, and I'm not sure if they can directly touch insulation. So I decided not to risk it. So all my light boxes are made out of 7-inch pieces of wood just to make a square, and it's entirely filled with Reflectix double-sided aluminum, as is all of the ceiling fixture just because of that direct heat coming down from the sun onto the roof. And then all the edges are sealed up with this great stuff, fire block. So it acts as both insulation and as a fire blocking material in case there are sparks and a small fire started. You can see it everywhere inside all the cracks and corners of my house, especially around wherever wires are running through. I still have some touch-ups to put in, but most of it's already done. So I went with this Chinese company called Zigbee. For a couple of reasons. The first is they are super cheap. They're only 20 bucks per light, and these are smart lights. So they're comparable with Hue down lights, which are about 35 bucks each. And the Hue down lights have this huge recessed format, which will not fit in 4-inch ceilings. These Zigbee ones, though, have just like 1.5 inches of thickness, so they can go easily into a 4-inch ceiling. So the way these lights work is they have these 2 butterfly clasps on the sides. They'll go in through the ceiling hole for the panels that I'm going to be putting above, and it just shoots up and snaps in, and it just holds it up in there so that the lights stay, and you can also pull them out whenever you need to change them or you decide to go with a different lighting feature. So these lights, instead of connecting directly to the power, they first go through this little smart block that's provided with the light. This block is actually a Wi-Fi hub, and it can connect to several different smart hubs, including Alexa, but it also can connect to Philips Hue lights. So again, all of my lighting in here is smart lighting, and it means that these are not only dimmable and set to different colors of white light, they also have tons of color features. All of these lights are hooked up to the Philips Hue app, and I can change them according to my mood. Like say we want a Savannah sunset. Oh, it looks amazing. Or say we want tropical twilight. Spring blossom. Tons of really other weird sounding themes, but basically I can set these to any kind of color control that Hue lighting can as well. So since we're doing a video right now, let's set this to concentrate mode. Very nice. Over here is my bathroom fan. It can move 70 cubic feet of air per minute, which is awesome for this small space. It'll definitely make sure there's no moisture buildup in the bathroom. So it has a couple different settings. The first setting, if you push the switch on once, this blue light comes on. The blue light means that it's testing for humidity in the air, and it will only turn on the fan whenever there's humidity present. You could leave this on constantly and just make sure that your tiny house isn't getting too humid. But if you're taking a shower and you want the fan on now, you just click it off and click it on again, and the orange light comes on and turns on the fan as a manual port. So as you can see, I have several different boxes with different AC ports in numerous places. Like over here in the corner, I'm going to have shelving and some speakers and maybe my smart system laid out up here. And then I have ports right next to the desk and the bed. I'm eventually going to have my propane heater right here, so this is going to be a big open space until then, which I'll go over my gas line stuff in a minute, so ignore that. So whenever I have different circuits hooking together, for example, this entire wall is one circuit, this back wall and the kitchen wall are one circuit. That way that there's not going to be too many appliances hooked into the same line and it'll trip the breaker. But whenever I have the circuits coming together from different boxes, I don't want those wires just hanging out inside the wall because it could lead to arcing and create fires and other sorts of problems. So what I do is I put all the wires inside these little connecting blocks. So these boxes are pretty straightforward. It just has the lines for different ones coming together and connecting together. These are my hot lines, these are my neutrals, and these are my grounding. And so these are 3-prong connectors, so this is connecting 3 different boxes. So it's first connecting the ones up here at top, it's connecting over here by the window, and then it's also connecting all the way out to the front box. Oh, this is on the same circuit as that wall. Huh. Yeah, so that's going out to the front utility box, so I have some power out there as well. And over here is interesting, because this is actually gonna have a little flip switch. I haven't installed it yet, but this one connects to the power from this outlet box. But then it goes over to the front, and it connects under the bed. So I'm gonna show you all of my plumbing here in a second, but this box is important because it connects to 3 things. The first is going to be the hot water heater, which is going to be situated over there. The second will be hooked up to the water pump for whenever I'm off grid, which will be housed right here. And then third is a small, just mini cubic washer, which will be sitting at the front of the bed and also connected to that point. And the idea is that I can switch off this switch and power off all 3 of those water appliances whenever I want. So 1, if they're drawing too much power, I can take them off the grid. And 2, I can make sure that if I'm gonna be out of the house and it's a cold day or something and the pipes spring a leak, that water pump doesn't kick on and just start pumping a ton of water into my walls. All right, so that's pretty much my power system. Let's go ahead and move on to my plumbing, which I haven't finished everything yet. But I'll take you through what I have and show you the stuff that I'm gonna fix in the next couple of days. So first off, I have 2 incoming ports into the tiny house. The first one up top here is for whenever I'm hooked up to the city water or a garden hose or anything like that, and I have continuous water flowing in through the house and the system. The second port is a port that is going to be connected to my water tank, which is here under the bed. It's a 30-gallon water tank, and that'll be for whenever I'm filling up my tank off-grid. So I don't have to haul water inside, open the bed, fill it up every time. I can just do it through a port outside using a water exchanger. Having each of these boxes exposed is really nice because I am using PEX piping. PEX piping is pretty commonly used in households nowadays instead of copper piping just because it's super resistant to bursting due to freezing. It can curve around corners pretty easily. You can have continuous lines without having to run multiple different intersections. So PEX is super cheap, easy to use, and I really like it. So for my piping, anywhere in the walls where there's continuous piping, it doesn't have any connections or anything, is going to be insulated and thrown deep into the wall. I'm not going to see it ever again, hopefully, because these things are resistant to bursting whenever it freezes, so I don't think I'm ever going to have any problems with that. If I do have problems, it's going to be where the pipes are interconnecting. Those are the places I'm likely to get leaks, or if the pipes freeze, that's where the water is going to come out. So I have every single interconnection for the house exposed so I can get to them and see them immediately and fix it. And I also don't have any water flooding into my walls. So let's just work our way around the house for the plumbing. So this top line is coming over here to this main shutoff valve, and that's for the city water or water hoses whenever I'm hooked up. The water inlet hose for the water tank comes here through the wall, and it has an outlet here. It's going to then be hooked up to the water tank right here. I can't put in all of that stuff until I have my flooring in, so that'll be a later video. So first off, coming in from city water, we have the on and off valve, which you know, it's pretty simple. You need it just so you can shut off the entire water in case of emergency. I also need this on and off valve because when I am off grid and I'm pulling in water from the water tank, I don't want water coming out the inlet for the city water, so that stays shut off. But right now, we're going under the theory that city water is on. Where are we running to? Well, our first intersection is down and over to the water heater. So that is cold water going down and over to the water heater, which will be situated into this corner. My second intersection right here is for where it hooks up to the water tank whenever I'm off grid. And so there's gonna be another shut off valve right here that can shut this off whenever I'm connected to city power. But whenever I am not connected to city power, I'm living off grid, I turn this connection off for the city water, and then I turn on this connection which hooks up to the pump and then to the water tank. So water can come in, it can go backwards and down to the hot water heater, or it can move forward through the system. But again, we're assuming we're on city water right now, so we're shutting this off, this imaginary beautiful switch, and then we're going back over to switch city water on. All right, over here we have my on-demand hot water heater. So I've already put through the exhaust vent, which goes through the wall through this thimble and out the other side. The thimble is meant to protect the insulation and everything inside the wall from the heat. The actual hot water heater is going to sit right here, and it has 3 outlets on the bottom. So the first is for the cold water to come into the system, which is going to be this pipe. The second pipe is for my hot water, and then the third pipe is for my propane. So once I have this whole system set up, I'll do another video so you guys can see how the hot water heater works, what's going on, and it should be pretty cool. Welcome to my kitchen. So over here is our second open box. Again, this is where we have some intersections. I want to be able to access these at all points. So we have 3 lines here. The top line is for cold water coming into the system. The middle line is for hot water coming into the system. And then this bottom line is a very special line. It is actually hooked up over here in the shower. It intersects with the hot water line right at the nozzle for the shower. So this is something I came up with, and I don't know why people don't do this when they're creating off-grid systems. So let me explain it to you. The hot water line goes over to the shower. It connects to the shower valve and then gives you hot water through the shower. But before it gets to the shower, it creates one intersection through a T. That T is going to have a valve on it, so it can be shut on and off. Then it goes through the T when the valve's open and comes back through the system through this third line. It then goes back over to the front water box and then comes out to the storage tank. So I'm using an on-demand hot water system. So whenever the hot water heater senses water is flowing through it, so whenever you turn on a hot water tap and it starts to flow water through, it kicks on and starts heating the water with propane. It takes about 20 seconds, and then you have hot water continuously for however long you want it. But in those 20 seconds that you have that hot water running, you're waiting there waiting for the shower to warm up, and you're wasting so much water, especially if you're in an off-grid situation where you have a very finite amount of water in your storage tank. So I created this system so I can turn on this valve in the shower, have the hot water circulating through, warming up through the water heater, and then once it is warm, I can shut it off and then turn on the main hot water valve for the shower, and I immediately have hot water. And all this time, I was just pulling water out of my storage tank, through the hot water heater, through the pipe in the shower, back to the storage tank, and dumping straight back into the storage tank. So it's just a continuous system. I didn't lose any water while I was heating it. Alright, so now that we've done all this, let's go ahead and talk about gas. So for my gas, I'm using entirely Home Flex system by Home Depot. All of this can be purchased through Home Depot and also found on Amazon. So first off, we have this 1/2-inch stainless steel piping. Inside is the corrugated pipe, and then outside it has this insulation cover. So the way my system is set up is the front utility box is going to house both of my gas tanks. And then those gas tanks are going to hook up to a pressure regulator, a leak detector, and a volume detector, so I know when my tanks are getting low. And then it's going to hook in to the exterior flange that's inside the utility box, and then connect to this direct line coming into this main gas manifold. So whenever there's a connection in this system, it uses the HomeFlex brass connections, which are super easy to use. It works through compression fittings, so it's a metal and metal compression fitting, but they're cinched down so tight and it creates such a fine seal that it becomes airtight. I think it's pretty awesome. It's ingenious. I don't quite get how it works, but you know, it works. So, coming into this manifold, we have the first brass connection connecting to the stainless steel manifold. This is from the main gas line from the utility box, and then it comes over. Ignore these two outlets because I don't need them, I'm not using them. These are going to be plugged with two stainless steel plugs, and nothing is going to come out. Then I have two outlets here and one on the end. This outlet goes down and around behind me up to this wall and is going to supply the gas for the propane heater. I'm going to have a Dickinson propane heater, which is a marine heater. They're a little pricey, so I'm just waiting until I can afford it. This right hand side goes over to the hot water heater and supplying propane to heat my water. And then finally we have this connection going over to the kitchen, which I'll show you where that is. Welcome back to the kitchen. I just brought you back over here real quick to see where the gas outlet, so that's this fourth line right here, this yellow line, is running here into the box. I'm going to hook up a valve here so I can turn it on and off, and then this outlet is going to hook up to my stovetop. So that's pretty much my system. A couple other things I wanted to show you was first my insulation. I have 1/2 inch Everbuilt foam insulation covering all of my pipes, including my gas pipes. That's so it just gives it a little extra protection for freezing water. And for the gas, during cold weather, gas pressure goes down. So that's just to try and keep the cold from accessing these pipes and to keep that pressure up a little bit. It can also act as a little bit of protection from any kind of jarring the trailer might undergo. Finally, we have these stainless steel strike plates, which are super cheap, like 40 cents a piece. And they just cover up any kind of holes going through the wall in which a electrical wire or a plumbing wire is running, or a plumbing pipe is running through. That way you do not go through your wires or pipe with a nail or a screw and totally messing up your system, having to rip out an entire wall, fix it. It would be a complete nightmare. By code, you're supposed to go through the middle of the studs with all of your holes, which I did, and it's 1.5 inches into the studs. I probably wouldn't have a problem, but I am super scared that I'm going to rip into one of these on accident by doing something stupid, completely forgetting there's a pipe there or something. And so I'm just having a little extra protection just in case. Alright, so that is my solar system, my electrical system, my plumbing, and my gas. All of these things seem super daunting to undertake. I know tons of DIYers go and hire somebody to do these parts for themselves, just because it's super scary to embark on things that could set your house on fire, blow you up, or cause intense water damage. But for those of you who want to do these systems yourselves, I'm telling you it's entirely possible, though I am saying I'm not a professional, so if I did do something wrong and I am going to die a fiery death, meander down to the comment section and let me know, please. Thank you. Anyway, there are tons of DIY videos on how to do this stuff. There's even tiny house books on how to do your wiring and plumbing. I actually bought one specifically for my electric system just to give me a general overview on how to go about it, because I had never done it before. So using all of these online materials, you can figure out how to do this stuff yourself, and I do recommend doing some of it yourself just so you know how your system works, and it gives you awesome skills to use in the future. So with all of that done, I am about ready to start insulating this sucker. So that's going to be over this weekend. I'm going to be using the Pure Safety R15 insulation in the entire thing, which is noise reducing. It's a fire retardant. I really like the brand, and because these are 4-inch cavities, I'm limited to what R value I can use. So this just turned out to be the best one. If you go back to my subfloor video, you'll see how I used it in my subfloor. But yes, I'm going to insulate the entire structure with that R15 insulation. I am going to seal up all the walls with a vapor barrier. And then I'm going to start putting on cedar paneling for all the walls and ceiling. And then also I have this really awesome life-proof flooring I got from Home Depot, which will also be going down in the next video. Yeah, overall it's gonna be a real house pretty soon. So stay tuned for any updates. Go over to my Instagram. I usually post as I'm working on there, just so you can see updates before the videos are made on how the house is going. Alright, if you like this video, give it a thumbs up, leave some comments below. I love encouragement, and if there's questions you have about your own build or you have some awesome recommendations, I love to hear them. Until then, that is a wrap. Thank you.